So first we have some definitions, independent versus dependent events. Independent means the occurrence of one does not affect the probability of the other, and dependent is the opposite. If one thing occurs, it affects the probability of the second one. So an easy way to think about it, independent. If I'm rolling a dice, okay, if I roll a 2, does that change the probability of getting a 2 the next time I roll it? No. Okay, if I have a deck of cards and I draw the 2 of hearts out, and I'm holding that 2 of hearts in my hand, does that change the probability that the next card would be a 2 of hearts? Yes. Yes. So the dice would be an example of independent. No matter what happened the first time, the probability is the same the next time. The cards would be dependent, because by pulling that one card out, it changed my probability. Now if I pulled my card out, looked at it, and stuck it back in the deck, would then the probability be different the next time? No. So if I put it back, then it becomes independent. So let's just practice deciding if things are independent or dependent. Suppose you draw a card from a deck and then roll a die. So drawing a heart, so pulling a heart out of the deck and rolling an even number. Are those independent or dependent? When I draw a heart out of the deck, does that change the probability that I will roll an even number on my die? No. So if knowing one doesn't change the other, it's independent. Okay, suppose 2 40-year-old women who live in the United States are randomly selected. The events: woman 1 survives the year and woman 2 survives the year. So I have 2 random people. I may have a 40-year-old woman in New York and a 40-year-old woman in Arizona. If the 40-year-old woman in Arizona dies, does that change the probability of the one in New York? No. So those would be independent. Okay, suppose I have 2 40-year-old women who live in the same apartment complex. The probability of woman 1 surviving and woman 2 surviving. So we might be tempted to say independent, but then we have to think of some possible scenarios. What if there were a fire in the apartment complex? Would that impact both of those women? Yes. What if there's a really bad illness that goes through the complex? Could that affect both of them? So, would these be independent or dependent? Dependent. It doesn't mean that just because one woman dies, the other could, but it means the probability might be different. Do you guys understand those? So today we're going to focus on independent events, where knowing one thing happens does not change the probability the other one happens. And for that, we are going to start finding the probability of both events occurring. So this is on your formula sheet, multiplication rule for independent events. The probability of E and F equals the probability of E times the probability of F. So we can extend that. If you had 4 things, you would do all 4 probabilities multiplied together. The key for this to work, they have to be independent, so they don't change one another. So kind of a summary so far. Last week we were focusing on OR statements, the probability of E or F. And when we did those, the OR told us we had to add the first plus the second. When I'm finding the probability of both and we are multiplying. Just as another review from last week, what does mutually exclusive mean? It's also sometimes called disjoint. And more specifically, if they are mutually exclusive, what's the probability of both occurring? 0. Mutually exclusive means it's impossible for both of them to happen at the same time. So this is kind of what we've learned so far. When we have an OR, all of our OR formulas told us we had to add. Today we're talking about and tells us we need to multiply. The other thing we know is that mutually exclusive means they can't both happen. So let's look at some examples. The probability that a randomly selected 6-year-old female will survive the year is 99.186%. What's the probability that 2 will survive the year? So what would I do? Yeah, I want the probability the first lives and the second lives. And means multiply. So the probability the first one lives is 0.99186. And so times the probability the second one lives, 0.99186. So we get 0.9838. How would I find the probability that 4 randomly selected women survive? Multiply it 4 times. Or if you want a shortcut, you could just take it to the 4th power. You get 0.9678. So, going along with this, what's the probability that at least one of 500 randomly selected 60-year-old females will die during the course of the year? So, the probability that at least one will die. So, that is actually, if you're just trying to calculate it, it could be pretty complex, right? Because at least one, that means 1 or 2 or 3, all the way up to all 500 could die. And it could be the first one dies and the other 499 don't, or it might be the second one dies and the rest of them don't. So there are lots and lots of combinations there. How could we find this probability in a reasonable way? What's the opposite of at least one person dying? Okay, close. The total opposite of at least one would be all 500 live, right? So we really need the probability of everything except that scenario where all 500 people live. So that's a complement. Remember we talked about complements, they're opposites. How do we find complement? We subtract it from 1. So all we have to do here is 1 minus the probability that they all survive. So to find them all surviving, 0.99186, and there are 500 of them. So there's a 98.32% chance that somebody will not survive the year. Why don't you guys read the next question and see if you can figure it out. So the manufacturer of exercise equipment knows that 10% of their products are defective. They also know that only 30% of their customers will actually use the equipment in the first year after it is purchased. If there is a 1-year warranty on the equipment, what proportion of the customers will actually make a valid warranty claim? So the only way they get a claim is if their equipment is defective, and the only way they're going to know it's defective is if what? They use it. If they never use it, they won't know that there's something wrong. So, are those things independent? Yes. What is the probability of being defective? 10%, so 0.10. Times, what's the probability that they use it? And so we get 0.0. So, only a 3% chance that they will have to replace the equipment. Do you guys get it? So, last slide I have is just kind of a summary of everything we know to this point. We know every probability must be between 0 and 1. And if you have probability distribution, all possible outcomes always add to 1. If they are disjoint, mutually exclusive, that means there is no overlap. So the probability of the first or the second, you just add them. If they're not disjoint, you add them, but you have to subtract off those people you double counted. Complement is 1 minus the probability of something happening. And last, our piece from today, if they are independent, the probability of the first and the second, we just multiply. So that is our stopping point. Following the same rules that we have been, so if the question asks you to find and interpret, you do not have to do the interpret.